Hello everyone, welcome back. So today we are going to talk about dental calculus. Okay. So we have talked about plaque formation, how the plaque forms and what are the effects it has on the dental tissues. So now we are going to see what will happen if a plaque is left in place for a longer period of time. Okay. So normally if you see any plaque, if it mineralizes, okay, it becomes calculus. So a calculus in a very simple terms, it means the mineralized form of a plaque. Okay, so the mineralized form of a plaque is called as calculus. The mineralized form of plaque is calculus. Okay, so a calculus can be a structure which is formed by various factors or various things from the saliva or from the bacteria itself. Okay, speaking to that, we shall move into the composition of a calculus. Okay, so you just remember one thing: any block left in place will become a calculus. Any calculus will have some amount of block overlying it. So calculus will have a block over it and under it. Okay, fine. Now coming to the composition of a calculus. Okay, so any structure, any composition of any structure, you can broadly classify it as organic and inorganic. Okay, organic content will be mostly glucose, fructose, which are nothing but carbohydrate, lipids like triglycerides, amino acids like glutamic acid, glycine, and certain macromolecules like chondroitin sulfate, dermatin sulfate, the ground substances. Okay, so you take a look at the organic content of a calculus. It is going to have carbohydrates, lipids, amino acids, and macromolecules. So in the carbohydrates we are going to have glucose, fructose. In the lipids we are going to have triglycerides, and in the amino acids we are going to have glutamic acids, glycine, alanine, and macromolecules we are going to have chondroitin sulfate, dermatin sulfates, like ground substances. Okay, the inorganic portion of a calculus is very important because it occupies almost 70 to 90 percentage, whereas this it will go around 10 to 30 percentage. So the inorganic portion of a calculus is predominantly made up of calcium phosphate. Okay, so calcium will be 39 percentage, phosphate will be 19 percentage, carbon dioxide will be 1.8 percentage, magnesium will be 0.9 percentage, and some miscellaneous ions like sodium and zinc ions. Okay, some sodium and zinc ions. So a calculus predominantly it will have inorganic, and in the inorganic predominantly there will be calcium phosphate. So calcium will be 39 percentage, phosphate will be 19 percentage, carbon dioxide will be 1.8, magnesium will be 0.9, and also there will be presence of some miscellaneous ions like sodium, zinc. Okay, now am I right in saying that whenever there is an increase in the pH of the saliva, there is going to be precipitation of calcium and phosphate because they are alkaline, right? So any situation which favors increase in the pH is going to result in increased formation of calculus. Okay, any situation which results in increased pH is going to result in increased precipitation of calcium and phosphate, isn't it? Due to increased precipitation of calcium and phosphate. Okay, now whenever I tell you there is going to be increased precipitation of calcium and phosphate, increased pH, then you should understand that whenever the pH increases, there will be increased precipitation. Increased precipitation results in increased calcium and phosphate. So inorganic content increases, obviously the calcium, the calculus is also going to get accumulated more. Okay, so this is the composition of a calculus. The mineralized form of block, it has organic and inorganic contents. So favoring increase in the pH environment is going to result in increased precipitation, right? Okay, now as we all know, there are two types of calculus. Okay, one is supragingival calculus, another one is subgingival calculus. Okay, so the term supra means it is above the gingival margin, above the gingival margin or marginal gingiva. Now you should be very familiar about what is marginal gingiva, right? Marginal gingiva is a portion of gingiva which is unattached terminal border and forms the gingival sulcus, right? So it is any calculus which is present above the marginal gingiva is supragingival calculus. Now any calculus which is present below the gingival margin is a subgingival calculus. Okay, supra sub, it's very simple and it is self-explanatory. Okay, now coming to a few things which you should know. Terminologies. Definition, as we spoke, any calculus which is present above the gingival margin is supra, any calculus which is present below the gingival margin is subgingival. Very good. Now what is it also called as? Supragingival calculus is also called as salivary calculus. Supragingival calculus is also called as salivary calculus because it derives majority of the nutrients or the energy from the saliva, from the particles or the components of saliva. Whereas your subgingival is also called as serumal calculus. It is also called as serumal calculus. Why? Because it derives most of the energy or most of the supply from the GCF. That is the reason the subgingival calculus is otherwise called as serumal calculus. Supragingival calculus is otherwise called as salivary calculus. Okay, fine, very good. Now coming to visibility, can you see a supragingival calculus through your naked eyes? Yes, obviously. So it is visible through the naked eye. Can you see a subgingival calculus? To some extent you can see, but you have to use some kind of a device or methods to visualize the subgingival calculus. The most commonly used method to visualize the subgingival calculus is by blowing air into the sulcus. And by blowing air into the sulcus, what I'm doing is I'm going to move the marginal gingiva as it is unattached. By moving the marginal gingiva, I'm visualizing the subgingival calculus, right? So it is visible through the naked eyes. Okay, it is visible through the naked eyes, but whereas your subgingival calculus, I have to visualize it with the help of a methods most commonly used, blowing this hair in the sulcus. Okay, so visibility, if you see, it is visible through the naked eyes. Here I can see subgingival calculus by blowing air into the sulcus. Okay, so this is the visibility aspect. Moving on to the location. So location, if you see, predominantly the supragingival calculus, if you see, it will be seen in the lingual surface of mandibular anteriors and buccal surface of maxillary posteriors. Can anyone tell me why? Why a supragingival calculus is predominantly seen in the lingual surface of the mandibular anteriors and the buccal surface of the maxillary posteriors? It's a very simple logic. Can anyone just recollect and tell me why? Exactly. Because of the opening of the major salivary glands, submandibular gland, Wharton's duct, opens into the floor of the mouth. First, the saliva comes in contact with the lingual surface of the lower anteriors. Parotid gland, Stenson's duct. Stenson's duct opened and the second molar region. So predominantly you see in the buccal aspect of the upper posteriors. So you see supraangial calculus induced in these two regions because of the openings of the major salivary glands. Okay, whereas in subgingival calculus I see predominantly in the interdental areas or interproximal areas regions. Okay, you have any doubts till now? Okay, now coming into the color. Okay, so color, if you see, the color of a supragingival calculus is white or whitish yellow in color. White, whitish or whitish yellow in color. Whereas the color of a subgingival calculus, if you see, it is going to be dark brown or greenish black. Okay, so the subgingival calculus, the predominantly the color is going to be dark brown or greenish black, whereas supragingival calculus is going to be white or whitish in color because of the source of minerals or the nature of each of the calculus. Gingiva supplies the subgingival calculus, and the nitrogenous pigments, something which is present in the gingiva, is responsible for the color change of the subgingival calculus. Supragingival calculus is majorly supplied by the saliva, right? So the color white or whitish yellow, subgingival it's going to be dark brown or greenish black in color, right? So now moving on to the consistency. So consistency, if you see supragingival calculus, it will be clay like consistency. So it will be pressable, it will be like clay like consistency, whereas exactly opposite is your subgingival calculus, it will be hard flint like. What is a flint? Flint is stone. Okay, so it will be extremely hard, it will be like a stone, whereas your supraangial calculus will be clay like. Okay, now attachment of a supraangial calculus is not that firm. Okay, whereas your subgingival calculus is extremely firmly attached. Okay, it is firmly attached. So the source of minerals, if you see, the source of minerals is predominantly from the saliva. There is less minerals present in your supragingival calculus. In your subgingival calculus, there is enormous amount of minerals present like sodium. Okay, so it is mainly supplied by the GCF. So these are all the basic differences between a supragingival and a subgingival calculus. Always remember the name: supra salivary calculus, subcerumal calculus, saliva GCF. Predominantly, whenever there is going to be an increase in the pH, precipitation of calcium and phosphate, formation of a calculus. The supragingival calculus will be clay like, whereas your subgingival calculus will be hard flint like, stone like. Right? Fine. Very good. Now, coming into the very important aspect and very interesting aspect, how a calculus forms. A lot of school of thoughts about how a calculus is formed. Okay, I'll tell you some 5 to 6 theories in a very simple way. Okay, so that you get to know about the various school of thoughts, and in case if they tell you or ask you some theory in the MCQ, you should be able to answer which theory is actually responsible for calculus formation. So now the first theory what I'm going to talk about is the carbon dioxide theory. So the carbon dioxide theory states that because of the pressure differences, okay, because of the pressure difference of of the carbon dioxide in the saliva and the environment, there's going to be escape of carbon dioxide. Okay, that is going to result in increase in pH. So whenever there is an increase in the pH, increased calcium phosphate, increased calculus. Okay, so the next theory what we are going to see is NH3 theory, ammonia theory. Okay, so in the ammonia theory what they state is the breakdown of urea. What is urea? Urea is a a compound which is present in your saliva, and there are bacteria which breaks down the urea. So similar way, some bacteria break the urea which is present, normally present in your saliva, into ammonia. So ammonia is extremely alkaline. Okay, so again, increasing the pH, that is going to result in increased calcium phosphate. Precipitation of calcium and phosphate occurs. Okay, the next one is the booster theory. So booster theory, if you see, it is a combination of the carbon dioxide theory and the ammonia theory. So he says that because of the escape of the carbon dioxide and because of the breakdown of urea, there is going to be calculus formation. So he combines both and tells that this is the combination of both the carbon dioxide and ammonia theory. The next one theory is epitactic theory. Epitactic theory, very important. According to this theory, the bacteria which is present in the block, okay, the bacteria which is present in the block is responsible for, okay, it is responsible for the calculus formation. Okay, it acts as heterogeneous, it helps in heterogeneous nucleation. Okay, so the block which is present in the bacteria, or vice versa, the bacteria which is present in the block, they help or they accelerate the production of calculus. They help in heterogeneous nucleation. Okay, in that way, calculus is formed by the bacteria which is present in the block itself. Okay, the next theory will be mineralization theory. So according to this theory, the minerals which is present in the saliva is responsible for the calculus formation. So the minerals which is present in the saliva is responsible for calculus formation. Okay, the next theory will be bacterial theory. So bacterial theory, if you see, some bacteria, they are capable of producing some enzyme like phosphatase, which is going to result in increased precipitation of phosphate. That is going to result in increased calculus formation. Okay, so at the end of the day, as I told, anything which increases the pH of the saliva is going to result in increase in calculus formation. So the first theory is carbon dioxide theory, ammonia theory, booster theory, epitactic theory, and then bacterial theory. So these are all the various theories and various school of thoughts on how a calculus is formed. Okay, excellent. So now coming to the mechanism of adhesion of a calculus. How come a calculus come or adhere to the two surfaces? It gets interlocked. Okay, it gets interlocked in irregularities. Interlocking of or calculus in root surfaces. Okay, so any irregularities in the cementum, the calculus gets lodged there, and also it attaches to the pellicle. So these are all the two ways by which a calculus attaches itself to the tooth. Excellent. Now that we know what is the calculus, what is the composition of calculus, what is the difference between supra and substantial calculus, what are the theories of calculus formation, how it adheres to the tooth surface, and now we are going to detect the calculus. The first and foremost detection is conventional. Okay, either through the naked eye or with the help of a three-way syringe. I'm going to induce air into the sulcus. I'm going to visualize the subgingival calculus. Right, so now coming to the how to find or how to detect a calculus. The first thing what you are going to see is perioscope. So perioscope is very similar to endoscope. Okay, so you will have a fiber optic tip with a lot of illuminating fibers. Okay, you will have fiber optic tip with a lot of illuminating fibers, and you are going to insert the probe into the sulcus and you are going to visualize in the monitor. Okay, so you are going to insert a fiber optic tip into the sulcus, and that tip is going to showcase you the calculus which is present, and you can see that in the monitor. This is perioscope, which is very similar to endoscope, right? Okay, next one is detector. Next one what you're going to see is detector. So detector, if you see, it uses light emitting diodes, okay, plus a fiber optic tip. So what it is going to do is, it is going to enter the sulcus and it is going to detect calculus by reflection, absorption, okay, and diffraction. Okay, reflection, absorption, and diffraction. So what happens when once I enter this fiber optic tip into the sulcus, so it is going to detect, or it is going to emit the light emitting diodes over the calculus, and because of some changes and reflection variabilities, it is going to detect the calculus like, okay, this is not the normal tooth reflection, this is something different from the tooth, so this can be calculus. So that in that way it detects the calculus by the differences in reflection and absorption and diffraction of a tooth surface. Okay, so detector. The last one is diagnodent. Diagnodent uses fluorescence. Okay, so what happens when I introduce this tip into the sulcus, it emits light, okay, of wavelength of around 650 nanometers. It usually detects calculus based on the structural differences, like it knows the normal fluorescence of a tooth. Once you enter the sulcus, it will detect, oh, okay, this is not a tooth, so we'll just emit light, and if there is fluorescence, then there is going to be presence of calculus. So there will be red fluorescence, and it detects calculus by the structural differences in the tooth. Okay, so you can get the value, get the fluorescence. So what are the three ways you can detect? One is conventional, that's normally what we are doing. Next one is perioscope, detector, diagnodent. Okay, so now coming to the removal of calculus. Okay, so the removal of calculus can be done in two ways. One is perioscan. So perioscan is nothing but the normal ultrasonic scalers, the piezoelectric ultrasonic scalers which we are using in our day-to-day practice, that will come under perioscan. The next one will be key laser 3. A beautiful thing about key laser 3 is it will detect calculus and it will remove the calculus. Okay, the key laser detects calculus with the help of a diode laser. Diode laser, wavelength of 620 to 650 nanometers, it detects calculus and it removes calculus with the help of erbium lasers, erbium YAG lasers, with a wavelength of 2400 940 nanometers. Okay, so it detects calculus with the help of a diode laser of wavelength 620 to 650. It also removes calculus with the help of erbium lasers of 2940 nanometers. Okay, so this will be the normal ultrasonic scalar. Okay, now fine, moving into the final aspect, that is the anti-calculus agents. I'll tell you three anti-calculus agents: triclosan, zinc ions, pyrophosphates. So these are all the three anti-calculus agents which is used to prevent the formation of calculus. right? So with this, calculus comes to an end. I hope you understood about calculus. Thank you for watching this video. Have a great day. Thank you.